Hello class, we're about to start section 13.4, graphing square root functions. Now it says recall, fill in the table for f of x equals the square root of x, then graph by hand. So if you look here, we have this table, f of x equals the square root of x, and we have values for x. We substitute in 1 for x, we substitute in 0 for x first, y would be 0. We substitute in 1 for x, y will equal 1, or f of x will equal 1. And we know y and f of x are the same value. Now we put in 4 for x, that means that would be 2, this would be 3, 16 will make it 4, 25 will make it 5, and 36 will make it 6 when we substitute. So, what we have here, we have these values, and we have this graph listed here. So what we want to do is to draw a representation of the graph, which we would have right here. Okay, class, and I took the liberty of inserting this graph already drawn so you can see the visual representation. We would just plot the points here, the x and y values, or we know y is f of x, and we would plot those points and then draw the graph here. And you know it ends with an arrowhead to indicate that it goes on forever. Now, we scroll down here. We want to know what is the domain of the function. Now, if you look at the domain, we look at all of the x values. Now, if you notice here, your first x value or your lowest x value is actually 0. And so, this is what we would need to do. So we will have our bracket, and it would be 0. And as you see, it is included. So that's why we have the bracket. And if you know, as far as your x values go, this goes on forever. So it would be infinity. So it would be 0 to infinity. Now we ask, what is the range of the function? We notice that our lowest value here for the y is 0. And it's included, so it'll be bracket 0. And if you notice, the graph keeps going higher and higher, so it will go to infinity. Now we come here to the third question that said the graph has a special point called an endpoint. Now the endpoint shown in this graph here is at 0.00, so we want to indicate that here. So it's called an endpoint in the graph, and then that's at 0, 0, or the origin. Now we come here to this next problem, which is objective 1. It says functions of the form f of x is equal to a times the square root of x. It says the graph of f of x, square root of x, g of x is equal to 2 times the square root of x, and h of x equals to 1/2 the square root of x are drawn. Now A, we want to label each graph. Now class, to expedite time, what I did here was I had all of the graphs done before we went over this lesson because they're kind of difficult to draw and trace over. So it says here, label each graph, which I did here. And this is how you could do it on your own. You could go right here to your calculator. And you can go to your y equals. So let's clear this out. And then let's turn off our stat plot if the stat plot is on. Let's turn that off. Go back to y equals. Then we could type in these values. We can make our y1 square root of x and press enter. Our y2, 2, and then the square root of x, and then enter, and then our y3, which would be a half, we can make that as 0.5 or 0.5 square root x. Now, like I showed you in times past, you could turn off the graphs to see how they work. So we could go to the equal sign, press enter, go up to the equal sign, press enter. So we could just look squarely at the square root of x. Now, because we've done some stat problems before, we may have to go to Zoom and go down to Zoom Standard. Oh, actually, I passed it, number 6, for it to graph correctly. As you see here, this f of x, you notice here that it's right here in the middle. Now, I don't have one of the color calculators. If you have one of the color calculators, it'll show each one of these as a different color. Now, let's go to the second graph. Now, we go to y equal. We'll turn on the second graph. We'll press graph. Now, if you notice, the second graph is a little higher than this graph is here. And then we turn on the third graph. Go down to the equal sign for the third graph. Press enter. And then graph. The third graph is right below. So we know f of x is the first graph, which is here in the middle. And then g of x is here. And then h of x is here, which I have listed here on this graph here. So now it says we have a rule here. If the absolute value of a is greater than 1, the graph is steeper than if the absolute value is less than 1. Now we come down here. We will basically do the same thing again in our calculator. You could do that at your leisure, but you will get these values here. And then you could come up with these conclusions. It says f of x is equal to a times the square root of x, and g of x is equal to negative a times the square of x are reflections of each other across the x-axis. Now we come here to C. It says if the absolute value of a is greater than 1, the graph is steeper than if the absolute value of a is less than 1. Now we want to take a look at the effect of a on the graph of f of x equals to a times the square root of x. Okay, if a is greater than 0, then the graph is increasing. So that's basically if this square root is multiplied by a positive number, then the graph is going to increase. Now, if a is less than 0, or we don't multiply by a negative number, then the graph decreases. So it's decreasing. And then if the absolute value of a is a large number, then the graph is steeper. So it doesn't matter if it's positive or negative. If the absolute value is a large number, then it's going to be steeper. If the absolute value of a is a small number, i.e. near 0, then the graph is less steep. So basically, whether it's positive or negative, if it's close to 0, it's going to be less steep. Okay, now we go on to the next page. Again, we have these graphs. Now, again, it takes a while to draw these graphs, so I just had it pre-drawn. It says here, objective 2, functions of the form f of x is equal to the square root of x plus k. The graphs of f of x equals the square root of x, g of x is equal to the square root of x minus 3, and h of x equals the square root of x plus 2 are drawn. It says label each graph, which again, you could put this in your calculator, and then you could clearly see how the graphs will be labeled. It says explain how the value of k affects the graphs. So this is what we would do. We would come down here to this general rule. And it says if k is greater than 0, the graph is shifted up. If k is less than 0, then the graph is shifted down. Now it says the y-coordinate of the endpoint is k. Now, one thing we need to know, again, we know that k is the number that's going to be added or subtracted to the square root of x. So now, we come here to objective 3. Now, objective 3, it says the functions of the form f of x is equal to the square root of x minus h. Now, if you notice here, all of these values are under the radical. When we did the previous problem, this plus k was outside of the radical. So it's going to have a different effect by being inside the radical. So it tells us here, it says label each graph. We have another graph here. And we have our three graphs. F of x is equal to the square root of x. G of x is the square root of x minus 7. And h of x is the square root of x plus 3. If you notice, these graphs have shifted. Now, if h is greater than 0, the graph is shifted right. So basically, it doesn't matter about this minus sign being here. Whatever the value of h is, if it's greater than 0, then it shifts to the right. Now it says here, if h is less than 0, which would be negative, the graph is shifted to the left. So basically what this is saying is if under this square root you have x plus a number, then that means that it's going to shift to the left. And then finally, the x-coordinate of the endpoint is your h value, or just h. Now, it says endpoint form of a square root function, f of x is equal to a times the square root of x minus h under the square root plus k. The endpoint is h and k. H would be your x value, k would be your y value. Now we go to the next page. Now I took the liberty of filling out this chart, and I will go through and explain this chart here, because as you all know on previous videos, this could end up jumping, so I just copied the chart here. Now we have the function f of x is equal to 4 times the square root of x minus 5 plus 2. Now we know the endpoint. When we go under the radical, if it's a minus sign and a number, it'll just be that number, and then also the number on the outside that's added or subtracted, so it'd be 5, 2. That'd be the endpoint. Now it says increases or decreases. It increases by 4 because 4 is multiplied to the x minus h here. Now it says shifted up or down. We know this is our k. That means, and it's positive, that means it goes up 2. And then shifted left or right. Since it's minus 5 and this does not change to a positive, it goes to the right 5. Now we go here. We have this equation here. And we know since this is plus 7, we will add negative 7, and it's minus 13. This would be negative 13, which would be our endpoint. And we know it's decreasing because this is a negative 1/3. And it's going down 13 because this is a negative. And then it's going to the left 7 because we know that since this is changed to a plus, we know this is really a negative 7. So it's going to the left 7. And then also as far as the decreasing is concerned, remember this is close, this absolute value is close to 0, so it'll be decreasing. Okay, now we have 5 times the square root of x minus 11. We know that it'd be 11 for the h value or x value, and since we don't have a plus k, it'll be 0. Then we know it's increasing because this number is greater than 1, so it's increasing. And then we know shifted up or down, we know that's dependent on k, and since that's 0, it's not doing it. And then we know it will go right 11 because this is subtract 11 here. Now we come down here. Now we know under the radical we don't have an h, so that's 0. And then we have this negative 16, so it'd be 0, negative 16 for the endpoint. Now we know this is decreasing because this is negative, this is less than 0. Our a is less than 0. And then we know we will be going down 16 because our k is a negative 16. And then shifted left or right, we have no number under the radical, so it would not shift left or right. Now it says here, which is the steepest graph? We know h of x is, because the absolute value of 5 is the biggest.